Hi, everyone, and welcome to another edition of Yacht Vlogs right here on Yachting International Radio. My name is Ria. I am your host, and I'm very pleased to welcome my next guest, Professor Icarus Allen. He is the Chief Executive of Plymouth Marine Laboratory based out of the UK. How are you?
I'm very well, thank you. It's good to talk to you this afternoon.
Yeah, what a pleasure to have you here. You are joining us to talk about the Arctic Abound, the Ocean Warrior Project. But before we get to that, tell me a little bit about you. How did you get into science, and what was your reasoning to get into marine science?
I suppose my interest in marine science started and ended with Jacques Cousteau. Seeing those TV documentaries in the 1970s, watching them diving the coral reefs, and that sort of lodged in my mind. It was never particularly conscious as I went through school, but it was always there somewhere in the background. I always enjoyed being at sea and going sailing and things like that. And I drifted into chemistry, studying chemistry at university. And when I came out of that, I spent a few years traveling and trying to find myself, and eventually drifted into doing a master's in oceanography, sort of returning to that initial whim. And it was a little bit on a whim. And out of that, I discovered I had a great interest in numerical modeling, particularly around marine ecosystems. And I was fortunate enough to be able to get a position at the Plymouth Marine Laboratory about 32 years ago now. So I started as a researcher modeling marine ecosystems, and I slowly built a career through that, eventually becoming Director of Science and then Chief Executive.
Tell me a little bit about Plymouth Maritime Laboratory. Now, it is unique in the fact that it is a charitable organization, which means that, of course, the information that comes out of it is completely neutral. It is facts only. There's no sort of bias in any direction whatsoever. Tell me more.
Okay, PML was originally a government research lab. We became a charity just over 20 years ago. And the purpose of the charity is really to do excellent science, to do unbiased science, present the facts, as you said, and really to do science with societal benefit. So we're trying to do things not just to understand how the world works and how the marine system works, but also to interpret it in terms of the impacts for society. So we're looking at man's impact on society and society's impact on man. Now we focus on marine ecosystems and marine biogeochemical cycles predominantly. So we're looking at three questions. Fundamentally, the first one is, how does the system work? So better understanding of the system. The second one is, how are we disturbing it? And what are the consequences of those disturbances? So that's things like climate change, that's things like microplastics, that's things like artificial light, that's things like pollution. And then we're looking at the consequences of that and really looking at solutions, mitigation and management. So how can we provide information that benefits society in its broadest sense, whether that's through education, whether that's through policy, whether that's through economic growth.
Let me ask you, a lot of years out there, and really basically myself even before I got into this space, we've seen a beautiful ocean out there. We go to the beach, we play in the water, we turn on our taps, but we don't actually truly understand the significance of a healthy ocean or healthy water. In a brief overview, can you explain why the study of the marine environment is so very important, how climate change is affecting it, why it's so very important to people to understand now?
Okay, it's really important on lots of levels. I mean, in terms of ocean physics, it's the enormous sink for heat from the atmosphere, and it acts as a buffering control on the climate. And one of the big changes that's happened over the last 20 to 30 years is the increase in ocean warming and the amount of heat stored in the ocean. And this is starting to have a fundamental impact on our climate. Secondly, the ocean is at the base of the food web of the phytoplankton. So these are photosynthetic algal cells, and they produce more than 50% of the oxygen we breathe. So there's a pretty fundamental reason for studying and understanding the ocean there. They also provide the base of the food web, and the responses of these organisms to climate have knock-on effects through the food chain, and particularly to do with fisheries. And of course, fish is a major source of protein, particularly in developing nations and coastal states. And the consequences of overfishing have enormous consequences for the societies that are dependent. If you then throw into the mix, we've now got microplastics in every part of the ocean. They've been found from the top to the bottom of the food chain and from the surface to, I believe, the bottom of the Marianas Trench. And things that weren't there, you go back to the 1950s and samples to then, there's no trace of them. I think it's in the late 1950s, the continuous plankton surveys, they've started to show even as early as that, they were starting to pick up plastic particles. But these things are pervasive. We're still trying to really understand what the consequences are for ecosystems and also the role they may play as a vector for transporting pollutants or pathogens. Then we look at more subtle things. There's a huge cocktail of man-made chemicals that we put into the environment, into our water courses and out into the ocean. And we're still trying to come to terms with what the effects of those are on not so much the acute effects, but it's often the more subtle chronic effects on organisms and their health, or indeed on their reproductive cycles. And there's a whole gamut of research to do that, and most of which we don't really understand what any of these chemicals do. So it's an immensely challenging and complicated problem.
Realistically, anything that goes into the ocean will end up eventually on your table.
I think quite a lot of pollutants end up stored in the deep ocean. There's no question about that. This deep ocean is a sink for carbon and partly helps mitigate the climate and the carbon in the atmosphere through the biological carbon pump, but also the deep water. A lot of this material will get taken down slowly into the deep waters of the ocean and be trapped there. But other aspects of it depends what it is. The more volatile chemicals will come out into the atmosphere. Some of the more soluble ones maybe come out into the atmosphere as well and be transported back onto the land. But and obviously anything we take out of the ocean will bring, like fishing or other, will bring things back onto the land. So it's an enormously complicated and multi-layered.
In the past 5 years, what sort of changes have you seen with the environment in regards to the ocean?
I think the biggest changes, I'm thinking locally around the United Kingdom, we're seeing definite trends in warming. And the temperature records we have in Plymouth go back to about 1900. And there's a very clear trend all the way from 1900 in surface water temperatures increasing. As the water increases, and there's a huge amount of evidence to show, we see changes in the phytoplankton community structure, and we see more and more warm water species. And then associated with that, shifts in the fish and the cetaceans and other marine mammals that are associated with that. But there is a general trend of warming, and there is a general trend, certainly around the UK, of warm water species progressing northwards and the cold water species retreating more and more to the north. And as a consequence of that, I think from a biological point of view, they're the most obvious things. And then we layer on that the activities associated with fishing and other human activities, the whole range of extraction industries, renewable energies, shipping, and all the other things that are going on in the ocean. It's an increasingly very busy and conflicted space.
Why is it that Plymouth Marine Laboratory was drawn to become part of the Arctic-bound Ocean Warrior project?
PML has been working in the Arctic for many years in a number of guises. And one of the big things that we've been doing there is looking at the consequences of ocean acidification. So this is the Arctic. As you draw down more carbon dioxide into the water, it becomes more acidic. And as a consequence, this impacts on the ability of various organisms to grow and reproduce, particularly those that form calcium carbonate shells, which obviously will dissolve in more acidic waters. Now, PML has been at the forefront of this research for over 20 years, and we've had a a not insignificant influence on bringing it to the agenda of the global policy through things like the UNCCC climate COP exit processes. So we've been there at the table for that. We've been doing this research. The Arctic is one of the areas where these impacts are thought to be most visible and is one of the most sensitive areas to ocean acidification. A big attraction really for us is having a ship that is going to be traversing these waters for the next decade and giving us access to these waters, the ability to be able to take samples, not just of carbonate chemistry in the water, but also the plankton associated with it, the temperature, salinity and oxygen, so that we can actually start to understand patterns in ocean acidification and how it's changing. That's the fundamental science driver. But it's around getting access to parts of the ocean that we can't see. There's another big piece of work we do at PML. We do a huge amount of satellite oceanography. So you're using ocean color satellites, which effectively measure the color of the ocean. From that, you can interpret how much plankton is there and to some extent the type of plankton there is. Now, this is dependent on having accurate measurements of the optical properties of the water and the light, and also of plankton in order to be able to calibrate these sensors. And the waters that the Ocean Warrior will be traversing over the next decade are woefully underrepresented. So it provides a really important opportunity to make a step change in the validation of satellites at high latitudes. And it's an exciting concept.
One of the things that a lot of people talk about when it comes to the Arctic is the fact that the ice flows are receding and at an alarming rate. What effect does that have on the planet?
As we have more fresh water in the high latitudes in the Arctic, we restrict the ability to form deep cold water, which sinks to the bottom of the ocean and drives the thermohaline circulation. And ultimately, this will impact on the ocean gyres and potentially lead to the breakdown of the ocean circulation gyres like the Gulf Stream, which will result in a fundamental change in climate, for example, in Western Europe, or indeed possibly in Japan, where the warm water that comes up from the tropics via the Gulf Stream over to Europe would be blocked, and we would lose that protection. So we'd have a fundamental shift in climate. So that's the first one. Secondly, the sea ice provides a habitat for all sorts of animals, polar bears, seals. And so you change the hunting and feeding patterns for them. It changes the whole plankton community structure, because where you have sea ice, the algae mostly grow just on the bottom of the sea ice. Whereas when you've got open water, you have a fundamentally different ecosystem of open water plankton. So there's a whole range of things that it changes, and all of these things then have knock-on effects through the food chain, the type of fish, the availability of fish, and all the way through to the charismatic megafauna of the Arctic, or indeed the Antarctic, your polar bears in the north, your penguins in the south.
Have you signed on to this expedition for the full 10 years?
PML has signed an MOU with the Ocean Warrior, with the expectation to be working with them for the next decade. So I'm off to Svalbard in a couple of days' time to take a look at the vessel and to really explore what are the scientific opportunities and what can we actually do with the vessel. What scope is there to instrument it? How viable is it to take types of samples? We're looking at obviously things like the availability of lab space, the availability of power, the ability to store samples, the ability to ship samples, types of instruments that we want to use there, getting a balance between high quality autonomous measurements, but also citizen science type and activities that the people who are participating in the voyages can actually join in. So we're trying to get a balance between the sort of high tech and things that the crew can do and to keep them engaged. So it's trying to get a balance there. It gives us an opportunity, as I said, to access waters where we wouldn't normally get them, and a continuous sampling over a decade. So in that sense, it's a really exciting scientific opportunity.
Going forward, this information is going to be out there for the public. It's going to be very transparent, so we can know that the numbers and the facts that are coming out of this are skewed any way whatsoever. That these are the facts. This is what's happening. And this is how we need to change. And I think that's really important in today's day and age when we have so many people expressing their personal opinions on what is truly going on with the planet, to be able to have these scientific facts, unbiased, in your face, in front of you, to be able to say, okay, this is what's happening and this is how we can fix it or change it or make it better.
Yes. Our job as an organization, we collect data wherever possible. We try and put it in the public domain. Much of the scientific community, and certainly in North America and Western Europe, is very much focused on data from the wider community for a point of access. And I believe that's a fundamental tenet of science. Then it comes down to the interpretation. And of course, different scientists will have different views, but that's all part of the process and part of the peer review process. And as we see over time, these views generally at some point tend to converge as we interpret the data. Now, PML, as you say, acts as an independent organization, and our role is to provide scientific advice as we see the facts.
So if people want to help further the research that PML does, are they able to donate to the lab?
Yes, we have a donations page on our website. We are always actively seeking funding. Running a marine laboratory is an expensive business, and it takes quite a lot of money to keep things going. We have funding from a variety of sources, including the UK government and research councils, and we have money from Europe, from the European Space Agency, and increasingly money from foundations and other funders. But we're always on the lookout for funding so that we can support our activities. And to instrument the Ocean Warrior, we will need to be proactively seeking funding to purchase the instruments to equip the ship, and also pay for the staff time in order to be able to run them properly and ensure we're producing high quality outputs that the whole world can use.
I am looking forward to watching this progress, and it may actually finally shine a real light on exactly what it is going on that can't be disputed for a change.
Yes, as I said, our job is to put the facts out there, put the data out there as we see it, partly for us to interpret it, partly for the wider community to interpret. And so through the peer review process, hopefully we will iterate towards an agreed conclusion. Science wouldn't be any fun if there wasn't any dispute sometimes about what things mean. And like many things in life, we collect data. It sheds lights on some things and often creates ambiguities in other areas. It's an ongoing process of trying to understand what's going on.
Professor, I want to say thank you so much for your time. It's been very much appreciated and very illuminating.
Thank you. You're most welcome.
You've been listening to Professor Icarus Allen. He is from PML, or Plymouth Marine Laboratory, and is part of the Arctic Bound, the Ocean Warrior Project. If you are interested in donating to either one, whether it be the laboratory itself or the project, we will be providing those links below here when this interview airs. You've been watching another edition of Yacht Crew Vlogs right here on Yachting International Radio. My name is Ria. I have been your host. We'll see you again next time.